When you're designing an optical subsystem for your medical device, it can be convenient to lay out the subsystem at an early stage of design on an optical breadboard or an optical cage system to test out key components of the behavior and key optical sensitivities early on before you finalize the design. I'm Brian King, and here are some of my favorite tips for laying out an optical breadboard system. First off, you should preserve the critical dimensions of your optical design, or what you know of it at that point in time, but feel free to play around with the detailed geometry to make it easy to perform adjustments and to see where the beam is traveling when you're standing beside the setup. It's convenient to put the beam a few inches or several centimeters off of the optical surface so that you can fit your hand under the beam without blocking it and easily reach into the center of the setup. It's good in early prototyping to build in adjustments, for example, kinematic mounts or lens mounts with XY adjustments or tip tilt, in order to give you the freedom to explore the sensitivities of your design and align the system with care in this breadboard layout before you have everything machined into something a little bit more permanent. Once you have the system roughly laid out geometrically on the optical breadboard or in the cage system, you can use index cards to trace the beam visually, or if it's an invisible beam, you can use sensitized cards that make the invisible light visible to your eye, and find out if the beam is following the optic axis of the system. For example, you can double check that the beam height stays consistent as the beam moves through the optical components. Use that index card to roughly determine where the beam foci are roughly. You can lay out the whole system and make sure that it's behaving roughly the way that you expect from your design before you install your more quantitative metrology, things like photodiodes, power meters, beam profilers, or imaging systems. And then move on at higher optical powers, at full system optical power, to verify the system's behavior. For more information, read my blog and follow us on LinkedIn.